So the first presentation today although the first presentations are on a project on urban segregation and inclusion. And they will all circulate around the same objective for the project, to use different digital techniques and tools to bring clarity on how people use the city of Stockholm over time, where they move, meet, and interact with each other, what resources they have access to, and how this knowledge can be used to develop our city in a better way. And our first presenter is Cate Heine from MIT. Cate, please join me.
Thanks, Lukas. And hey, everyone. As Lukas said, my name is Cate, and today I'm going to talk to you about our research measuring and mapping integration across Stockholm. Cities, including Stockholm, are diverse. They're made up of people from different educational backgrounds, income levels, and nationalities. But just because two people live in the same city doesn't necessarily mean that they interact with one another. It's natural for people to live, work, and socialize with people who are like them in certain ways. But when this reaches an extreme, it can create a situation where entire neighborhoods or groups of people don't interact at all, segmenting the city, fostering mistrust, and exacerbating inequality issues. It's easy to map and identify residential segregation, areas where people live with others who are very similar to them. For example, in Stockholm, many immigrants to Sweden are concentrated in just a few neighborhoods of the city. But people don't just interact with the people that live near them. They move around the city as they work and socialize, potentially interacting with people who are from very far parts of Stockholm. So our question is, as people move through the city, working and socializing, do they interact with people who are different from them? Or do they remain segregated in their social interactions? This more dynamic type of segregation, which we'll call social segregation, is undermeasured and understudied. Which leads us to the two main objectives of this study. One, map social integration across Stockholm. And two, identify the types of spaces, things like green spaces, in parks, schools, museums, that are particularly good or bad for integration. In order to answer these two questions, we needed to tap into non-traditional data sets that allow us to observe how people move throughout the city of Stockholm. We first looked at a set of hundreds of thousands of geolocated tweets that tell us exactly where they were sent from. Using this data, we define a measure of connection between any two neighborhoods in Stockholm, and we map this. We want you to go to our website and play with this map, interact with it, and uncover exactly what we found in terms of the connections between neighborhoods. But overall, we found two major findings, some good news and some bad news. The bad news, people are more likely to travel through neighborhoods that are similar to one another, only poorer or only wealthier neighborhoods as they move throughout their day. But the good news is that there's a lot of variation within this. There are some neighborhoods that are much more integrated within Stockholm. So after identifying this overall effect, we wanted to dig deeper into what this means for lived experience for the residents of Stockholm. How likely are individuals to be exposed to people who are different from them or similar to them over the course of the day? And where does this exposure happen? Are there specific types of places, green spaces, parks, that are really good or bad for integration? So in order to do this, we weren't going to be able to use tweets. We needed high density, really fine-grained data, which is hard to find. So we partnered with Telia, one of the largest telecommunication companies in Sweden. And they were able to provide us with a really uniquely valuable data set. Hundreds of millions of data points describing how their users move throughout the city of Stockholm. Importantly, all of this information was anonymized, aggregated, and synthesized before we used it to make sure that we were protecting user privacy. From their data, we calculated an index that describes how diverse the group of people gathered in any one part of Stockholm at any given time are. And when we mapped this index, we found that there's significant variation across Stockholm and over time. So a natural next question was, how can we describe this variation? How can we explain it? What types of spaces have high integration or low integration? And as a first case study, we zoomed in on schools. And we found that municipal upper secondary schools do have a significant positive impact on integration. More diverse groups of people economically gather in and around those places. And interestingly, this effect holds on the weekends as well. indicating that schools are able to pull together diverse groups of people even outside of school hours. So in summary, using 2 different geospatial data sets, we were able to map integration and segregation across Stockholm. And we hope that these maps can serve as valuable tools for citizens and city planners of Stockholm to identify areas in which we're doing well and areas in which we could do better at fostering interactions between diverse groups of people. And 2, we were able to quantify the specific effect of upper secondary schools on integration, highlighting them as a potentially valuable integrative public space. By expanding this type of research to other amenities like parks and transit stops, we're hoping to enable city planners to really plan for a more integrated Stockholm, where resources are exchanged among all its residents. Thank you, and with that, I'll pass things on to Anne and Daniel.
Thank you, Kate. And now, that's very nice. Anne Legeby and Daniel Koch from KTH, please.
Hi, we will tell you more about a study that is called New Urban Habits. This is a study about how we use the city and what places that are important. We also want to link this to segregation and to unequal living conditions. So we asked people to map on a web-based questionnaire what places they are using and avoiding, and maybe some new places. So we wanted to know more about how habits change during the pandemic. How do urban dwellers use the city when there are restrictions as physical distancing? We also want to know more if there are differences as neighborhoods are compared in terms of what they offer or perform, how these areas perform. What places and functions, amenities have been important for people during the pandemic? And then we want to link this to the living conditions. How can we map living conditions, and how does it link to how we use the city? If we look at the places that people still visit, we can see that they actually use a lot of them. And it's important to highlight that this is primarily to study or to work or to use service. If we look at places that are avoided, we can see a concentration to the inner city and places that normally are very crowded. If we look at the places that are avoided, it's a different pattern. These are much more distributed in the city.
And we can look at, it's important to also say that when we talk about these uses, we can understand why people go to places. It's because of the self-reported, the respondents tell themselves why they visit places, which enables us to understand why they visit a certain park, for instance, without assuming too much about what the park does. And this is what we see in these different diagrams of places I still visit, I visit more, and I visit more seldom, and places I visit more. But we can also see that, like in this diagram, that of course the big change when it comes to the pandemic was that there was a lot of places that were used less, for instance, and only a few that are used more. By doing this, we can also compare, like Anne said before, to urban patterns and plan things. So here's just a comparison between places visited more and parks in the city. And we can see that the majority of them actually are located inside parks for various reasons, where the 2 big reasons for parks is whether they are easy to reach and whether they provide seclusion, for instance. We can also look closer at how areas perform, and here we see Södermalm. So we can see that Södermalm during this crisis actually manages to allow a lot of activities to happen locally within Södermalm, but we can also see how much of the city in this pink dots actually disappeared from the geography of inhabitants from Södermalm. So it managed to take care of many things, but it also isolated itself in like quite significantly. So there's a dual to that thing. And by doing that, we can also see how different areas perform as different kind of profiles. So we can see that Södermalm, again, very close, whereas others have quite a lot quite far. And then we can see that some areas, which is probably due to the morphology and the context, have only close and far away, but nothing in between and so on. So we can start to see how they act as a contextual situation.
Yes, and to be able to link this to urban planning, to urban design, we also want to map out the living conditions in each areas. So what we have analyzed is the accessibility to services from each address point in the whole city to service on the one hand and to parks and green areas on the other hand. And then we can start to find out more how the different neighborhoods perform and also support the planning practice to formulate new strategies. In the next phase of the study, we will now continue to analyze the whole data set that is much more comprehensive and includes answers from 1 year's time. So this is very interesting to continue with. We have more than 4,000 people that have answered, and we have more than 16,000 places reported, exactly what they're doing there, where they're going there, and also how it has changed during the pandemic. In the end, we want to link this to urban form, to different types, to learn more how we can build a much more resilient and a more equal living condition, to provide more equal living conditions in Stockholm. Thank you.
Thank you. Thank you, Anna and Daniel. You're welcome to sit down.
Thank you.
Thank you very much. And our next presenter is Tom Benson. Please join us.
Thank you very much.
I'll do my round here.
Hello, everyone. Today, I'm going to present to you the project called Neighbourhood AI, Seeing Change. Rinkeby, oh, sorry. I'm going backwards. Rinkeby is a neighbourhood in Stockholm. Let me tell you a little bit about it. It was part of the Million Programme, where during the 1980s, many houses constructed across the city. However, over the past few decades, it has seen large social unrest, high crime rates, and in 2019, it was labelled as an extremely vulnerable area for Sweden, only with 21 other neighbourhoods for the whole country. There are also several other neighbourhoods which have been labelled as vulnerable areas in the city of Stockholm. However, it's not just neighbourhood decline as well, it's neighbourhood ascent. Tremendous pressure and extreme costs can be placed on low-income families and elderly people who have a fixed income. The neighbourhood Sharpnack is actually currently seeing signs of gentrification through the displacement of low-income families. But what about if you could see these changes? What about if you could predict future change and help neighbourhoods like Rinkeby and Sharpnack to decrease these negative cycles of urban change? And I really like this quote by Alan Jacobs in his book, Looking at Cities. Clues help the observer understand the nature of the urban environment being examined. They help answer some of the questions about the past, the evolution, and the present state of an urban area. And when he talks about clues, he means visual clues. He means, for instance, if you see a 1920s house that has 4 doorbells, 4 postbox, 4 telephone lines, it's a 4-dwelling unit structure house. But if a single person lives there, it means that change has happened. Change has occurred in this place. If you see construction work down the street, it means change is coming. And how he measured these was through what he called the observer. And he himself was the observer, a manual process of measuring the physical environment. But what if you could use artificial intelligence to automate this process for the whole of Stockholm through the visual clues? The physical, social, and economic aspects of cities are changing continually and are often entwined. When something new appears, the residents, the representatives, they react to these changes. But instead of reacting, why don't we forecast change and act more proactively about these issues? Neighbourhood change is complicated to measure, but we can do it through visual observation. So the key objectives for this research are to anticipate fluctuations of neighbourhood upbringing and decline for Stockholm in 2029 and reduce these negative cycles of urban change. And it's also to find the visual clues and find the different typologies of neighbourhood change, such as gentrification and exclusion. So how do we automate this? How do we become the observer? Well, we use artificial intelligence and machine learning to forecast 10 years in the future. We use Google Street View images to extract visual patterns over the past 10 years, which provides us with a comprehensive overview of the aesthetics of neighbourhoods. We measure this from a qualitative but also from a quantitative point of view to find the past 10 years of changes from 2009 and 2019. We then construct 2 predictions for the status of neighbourhoods. We find if neighbourhoods are ascending, declining, or stable. We then do a second prediction in more detail about the different typologies of neighbourhood change, such as gentrification and exclusion. And some of the visual clues that we find are number of roads, number of streets, sidewalks, which then become very fine-grained detail for the city to understand. And these are very particular features of the physical environment. And to conclude, even though this research is still in progress, it's not been peer-reviewed yet, we believe that we can create a tool that monitors neighbourhoods and then provides us with the ability to decrease the negative cycles of urban change. Thank you very much.
Thank you very much, Tom. And now to the final presenter in this project, Oskar Västberg, please.
Thank you. Hello. So in this study, we have used mobile phone data from Telia to estimate a model of how people travel in Stockholm. And we have then used that model to simulate how people in different areas of Stockholm travel and interact. So travel demand models are used extensively in Sweden and all over the world to analyze how people might change their behavior due to, for example, new subway lines, a congestion charge, or new roads. At the Division of Transport and Systems Analysis at KTH, we have for years developed the so-called activity-based travel demand model, which we call SCAPER. So the model describes how people travel within Stockholm, the number of trips they perform, their activities, when they travel, and the mode of transport that they use. SCAPER explains people's behavior with travel times, cost, land use, and so on, and can therefore be used to predict how they will change their behavior due to changes in these attributes. But to correctly link these attributes to behavior, we need data on how people actually behave. Usually, we use travel surveys for this purpose, where we know the travel pattern. But in this project, we have developed a method that allows us to estimate SCAPER on mobile phone data, where we do not know the mode of transport, type of activity, or even when and where a trip is being performed. We only observed an anonymized sequence of cell towers and timestamps following a mobile phone. So mobile phone data allows us to observe differences between smaller groups in the population. And for example, estimate different models for different residential areas. We developed a method that, very briefly explained, generates a travel pattern that both overlaps with the observed cell sequence in time and space, and also match with how the model itself believes that people behave. We then estimate the model so that we reproduce aggregated moments within these travel patterns. So we thereby update what's probable according to the model, and we then iterate this process. Finally, we obtain a model which depends on aggregated statistics in the anonymized mobile phone data. So since the project was performed during the COVID-19 pandemic, we could compare model results based on models estimated before and during the pandemic. So these graphs show the simulated interaction between people living in certain low-income zones, which is the top map with green areas, and a number of different areas characterized by higher income levels. And the top plot shows the interaction before the pandemic in November 2019, and the lower plot here shows the interaction we have simulated in November 2020. And what we can observe is that the areas which originally had a higher level of interaction continue to have a high level of interaction hereafter, after the pandemic or during the pandemic, whereas the areas that originally had a lower level have a decreased level of interaction. So travel patterns has clearly changed, and we picked this up by estimating our model. We find that the simulated distances traveled decreased substantially in the high income areas, but negligibly in the low average income areas. We also looked at travel times and we found that the simulated average travel times of trips that were labeled as work trips decreased in both of these areas, but a lot more in the areas characterized by higher income. So finally, here we have a simulated effect of the construction of new work locations in different areas of Stockholm. The darkest red colors are where the new work locations are located, and the darkness of the color indicates how probable a person in that area would be to work in these new work locations in the 4 different scenarios. The real strength of a model such as Scaper is that it can be used to evaluate possible future scenarios. The accuracy of such predictions will depend on the quality and the quantity of the data that's used when we are estimating the model. And the methods that we have developed within this project, we think will contribute towards allowing us to use new and bigger data sources when we are estimating travel demand models. Thank you.
Thank you very much, Oskar. Please have a seat, and we'll ask 2 more researchers. No, 1 more researcher, and Daniel, who is my colleague from the city. Fábio Duarte and Daniel Andersson, please have a seat. Yes, it's been very interesting to listen to you. My first question will go to you, Cate, since you've been sitting for so long. What are the future directions that you're hoping to take in this project? Are there any more? You mentioned it a little bit, but are there any more amenities that you would like to focus on and to study a little bit more?
Yeah, that's a great question and something we've been thinking about a lot. I think 2 of the main amenities that we're interested in are parks and other types of green spaces and transit stops and the transit network in general. The research that Anne and Daniel presented just now pointed out some of the importance of parks, especially during the COVID-19 pandemic. There's so many beautiful parks in Stockholm, and they seem to be increasingly important gathering spaces for people. So understanding how they play into integration and segregation, I think, would be a really interesting question. I also think that the question of how public transit plays in to integration kind of underlies all of the research that we're doing, in that we can build, schools, we can build open green spaces for people to gather in, but people won't be able to come visit and gather and interact if they can't physically reach those places. So just trying to understand how much integration depends on access via the transit network, I think, is something we're really interested in. But we're also really excited by our collaboration with the people in the city, you, Lukas, and you, Daniel, and also getting feedback from people in Stockholm about what's really interesting and important to everyone else. So looking forward to feedback on that as well.
Yeah, we too. And then Daniel and Anne, you studied or harvested the possibilities that were given to us due to the pandemics. From the first month of analysis that you did, what kind of places are still visited and for what reasons? And what can you say about the places that are visited more?
Yes, we can see that a lot of places have been continued to be visited. So yes, we have changed our habits, but we have still, a lot of people had gone to work and where they study and go to look for service. On the other hand, we can see that places that are visited more, it has been important to reach service, to reach parks and green areas. And those 2 combined says something about how to build. How dense should we build? How accessible? It says something about urban form. So this is what we want to continue and look more carefully at and do more comprehensive studies about accessibility to different functions and amenities.
Yeah, it's within our toolbox, so to say, to change those things. Tom and Fábio, your project, the Seeing Change, is a little bit different than this one with a predictive model. But how can you say that this kind of work would be turned into a planning tool in a way?
Yeah, I think it's interesting because the dimension that we have in this project is time. And time is continually updating, of course. So we can actually use more data as time goes on into our models to improve the predictions. We used 2029 as the output because we only had 10 years of data of Google Street View images. But every year this is being updated. So actually we can create real-time predictions of neighborhoods for 2025, 2030, and so on. So I think this could be useful as an early warning system to protect neighborhoods from these negative cycles of urban change.
And then when we are at 2029, we can evaluate your model. Right?
It can be continually be evaluated, which then can improve the predictions.
Actually, I think the goal is to not confirm the model, but to reject the model. if we see changes happening, and say, "Oh, this change is bad. Let's act beforehand."
Exactly.
That's the power of the tool.
Yes, correct. Okay, so I just want to ask you some maybe an awkward question. I know that you answered it a little bit in your presentation here, but both you, Cate, and also Oskar have been working with Telia data, and everybody is carrying around their mobile phones. But how did you work on the integrity part? How did you manage to do it without risking personal integrity?
Yeah, it's a really important question for any type of data that contains people's locations. No one wants to feel like their locations are being tracked as they're moving around a city. And luckily, Telia was really careful about this and worked really closely with us to make sure that we were living up to their standards in terms of data privacy. So all data was anonymized before we received it, so it never contained any personal information. But beyond that, we in our project, and Oskar has his own kind of privacy workflow as well, but we were only working with aggregate information. We weren't working on individual traces of people moving around. We were looking at how many people who live in neighborhood A are located in neighborhood B at a given time. So by aggregating up to kind of these lump numbers and just looking at that, we were able to ensure that we weren't really looking at personal information. And beyond that, once we aggregated information, we also took away some of the signal and added a little bit of noise to ensure that we weren't just working with aggregate information, we were working with a little bit messier aggregate information than the ground truth. But Oskar, I'm sure, has more to say about it.
Yeah, I mean, all the first things you're saying are the same for us, but in terms of how we then use the data, we are, as I'm saying, estimating a model to reproduce certain aggregated statistics within the data. So we are never reproducing any individual travel movements. We are just reproducing things on an aggregated level. And then we are only analyzing data which we see through the lens of our model, basically. So that's how we solve it.
Okay. And in your project, you use the Telia data to update or to create a better scaper, maybe. Yeah. And you showed us an example of simulations that you could do on workplaces. What other kinds of utilities could there be for the city?
Yeah, I think. So Scaper is a travel demand model, and I think some typical examples of what you could use a travel demand model for would be analyzing different land use scenarios. So what happens if we are building new workplaces in a certain location, or if more people move into a certain location. I think what Scaper is especially good at is analyzing like time differentiated policies across the day. So for example, if we want public transport prices to have a peak price and off-peak price, that would be something that Scaper is particularly well suited for.
Okay. And also to look at land use or different kind of land use. So we could actually combine the studies that you have made with the ones that you have made, and then it will be good, I think. So what do you think, Daniel? You work as a strategic planner. How would you like to use these kind of technologies when they are at our disposal?
I think there's a big potential, looking at many of the studies, to implement new tools at our office within, let's say, 2-3 years. But I would like to highlight the scalable potential that we are working currently right now, because it's so extremely concrete. We are working on an office strategy, trying to find out what would be like the best positions in the new urban geography to establish new office clusters. So with Scape, we could, for example, understand if we have several opportunities, which is the one that people would prefer to go to. Will they go to the ones we propose, or would they go to a neighboring municipality? Or what alternative would actually give the biggest impact on transport modes? what would give more car use, what would use more public transport use, for example.
Yeah. This is good, because then there would be like a use for this kind of development that is not only within the city but for also other actors. And if I ask you, Tom and Fábio, besides the municipality, how can citizens benefit from the predictive model that you have for neighborhood change?
I think one of the benefits that the residents could have is actually to monitor what city is doing. Because if they know, okay, this is how we're predicting changes, and they could come to the city, okay, look, this change might be bad. What are you planning to do to avoid this change to happen? So I think this is can be a powerful tool also for citizen engagement.
Yeah, as a part of a citizen engagement scheme, just to
Yeah.
be transparent,
Yeah.
but also to try different modes, maybe. What happens if we do this? We use the model that Oskar has has built, and then we try different scenarios, and then we can communicate it maybe with your tool. It's very good. I think that was my final question. I'm very happy having you here, and I look forward to work with you in the next year to come. So please, we will rearrange a little bit. Thanks a lot.